holography is best known from the ADS CFT correspondence, and that's, of course, very closely tied to M theory. So I didn't know that holography was a general feature of quantum gravity.
Yeah, that's an interesting point that you're making, a very good question. So far, in what I've said, I've used the word holographic principle and holography in a way that it would have been used 20 years ago, or 15, 20 years ago. 20, 25 years ago, I should say. And referring to patterns in the distribution of quantum information in space-time that we sort of recognize and find puzzling and find fascinating, and then try to sort of understand how to, first of all, describe them in a systematic way, and then maybe understand the deeper origin. Holography today is used mainly synonymous with something called the ADS-CFT correspondence, which was discovered by Juan Maldacena in 1997. And that is a theory of quantum gravity. It's a complete theory of quantum gravity, unfortunately for spacetimes that are not like ours, but which nevertheless allow us to ask many deep and interesting questions. For example, in spacetimes that are ADS, anti-de Sitter, some shape of space and time that we don't happen to be living in. But in such a spacetime, you can still make black holes and ask what happens when they evaporate. And Maldacena's theory tells us what happens, namely that no information is lost. So it's an incredibly powerful framework that immediately answers one of the most important questions that we can ask about quantum gravity. And because it's so powerful and it is a complete theory, it has been incredibly useful, not just in quantum gravity, but also in many other branches of physics. You can actually use gravity to learn something about strongly coupled quantum field theories and so on. In fact, most of the first few years of work on this correspondence went in that direction. And so it has really dominated the work of, probably tens of thousands of physicists over the last few decades. And because it followed shortly after Lenny's and Hoft's papers, and it did sort of realize this notion of holography in a specific context through a quantum gravity theory in which there sort of weren't more degrees of freedom to start with than what fits on the boundary of the space-time. It rightfully was called a holographic theory. And then since that's where 99% of the work was in the field, it eventually became just synonymous with holography. That's what. So that's fine. That's just a linguistic question. So now we're sort of in a situation where saying holography could be, well, for most physicists, I think it would. If you don't qualify it in any other way, then it would just refer to the ADS-CFT correspondence. That's not how I refer to it here. The way I would fit in the ADS-CFT correspondence is like it's more narrow in that it only pertains to a particular class of spacetimes, whereas the kind of ideas I talked about in the context of the holographic principle are completely general and work in our own universe as well. But it's also, the ADS-CFT correspondence is also much more complete. It's not just a pattern, a hint. It's the theory. For those spacetimes, that's it. It's a complete theory that describes what is going on. And so, and it's been incredibly valuable, not just because it told us that information comes out of black holes, but because in many other ways it can help us cross-check our ideas about quantum gravity more generally. And so it's been a very complex and fruitful back and forth between people asking about quantum gravity in spacetimes like the one we live in, and people more focused on exploring and understanding the ADS-CFT correspondence. I've certainly worked on both things.